This video covers chapter 15 of the Higher book, and it's on equations and inequalities. So we're going to start with the first bit up here and looking at linear equations. So linear equations are not going to have x squared in them or anything like that. They're just going to be equations which we can solve by balancing. So we'll do a few of those. So for example, if I had 6x minus 3 equals 25. So the first thing we do is add 3 to both sides, and that would give us 6x equals 28. Then we divide both sides by 6. So always write down your steps like this. So we will have x equals 28 over 6. That's fine to leave it like that. We could simplify it. If you divide both by 2, we'll end up with 14 over 3, which if you want, you could change to a mixed number. 3 goes into 14 4 times with a remainder of 2. So you could write any of those as an answer. Okay, let's try one that requires a few more steps. So let's have 2x minus 5 equals 7x plus 2. So always start with the x's. So I'm going to take away 2x from both sides. I want to keep the x positive, so I'm not going to take away 7x from both sides. So I'll have negative 5 equals 2x plus 2, and I'll take away 2 from both sides, and that will leave me with, and you need to be careful here, it's negative 7 equals 2x. So divide both sides by 2, divide by 2, divide by 2, and that will give me x here, and that'll give me negative 7 over 2, and we will just flip it around to give us x equals negative 7 over 2, which we could write instead as negative 3.5. So let's try one now where we've got some brackets. So if we have brackets, we need to expand the brackets first. So we'll have one here like this. So expanding the brackets first is going to give us, let's put the arrows in to show where we're expanding, like this. So we would have negative 8x plus 10 equals 12x plus 20. So because I want to keep the x's positive, I would add 8x to both sides rather than take away 12x from both sides. That keeps the x's positive, just makes things a bit easier. So I'll have 10 equals 20x plus 20. I will take away 20 from both sides. So that will give me, well, 10 minus 20 is negative 10 equals 20x. Then divide both sides by 20 like this. And then I will have x on this side, and negative 10 divided by negative 20, or say negative 10, sorry, divided by 20, which you can just flip around and simplify, and that becomes minus a half like that, or minus 0.5. So that's solving linear equations. Follow the steps, and that also does this as well, because we've looked at ones where we've got the letter on both sides, and it's just a small step to apply this to real life practical problems. Just turn the problem into an equation and solve it. So we now move on to the next bit here, which is solving inequalities and represent the solutions on a number line. Now we solve inequalities in exactly the same way as equations. Okay, so that means we use balancing, The only thing we need to watch out for is this. If you multiply or divide by a negative number, and if you multiply or divide by a negative number, then reverse the sign. Okay, which basically means you just flip it the other way around. So let's do a couple of examples. So if I had 7x minus 3 is greater than or equal to 4. So the first thing that you do is to add 3 to both sides, just like you would with a normal equation. So we'll have 7x is greater than or equal to 7. So keep that symbol there. Divide both sides by 7. So we'll have x is greater than or equal to 1. Now we can show this on a number line. So if I were to draw a number line like this, and I put 0, 1, 2, 3 like this on a number line, what I would have is on the number 1 I'd have a coloured in circle and I'd have an arrow to show this carries on that way for all the numbers greater than or equal to 1. Now when we have these types of diagrams, we have this symbol, so an open circle will be for when we have a greater than or less than symbol in our calculation, and we will have a coloured in circle like this for when we have a greater than or equal to or a less than or equal to. Do you have a coloured in circle? Let's try another one. Now sometimes you can get what I call sort of two-sided inequalities, so you can get something like this. 10 less than 5x plus 2 less than or equal to 17. Yeah, and what it's like 3 sides to this equation. So we're going to solve all 3 bits together. So I'm going to take away 2 from all 3 sides. So I'll have 8 less than 5x less than 15. Like that. Then I'm going to divide all 3 sides by 5. Like this. So I will have 8 over 5 less than x less than or equal to 3. Now we can show this on a number line. The number 8 over 5 is 1.6. So if I was showing this on a number line, it would be my number line here. Let's do 0, 1, let's put 1.6 on, 2, okay, and 3, like this. So something like that. I know it's not to scale. So above 1.6, we would have a circle which isn't coloured in. Above 3, we would have a circle which is coloured in, and the 2 would be joined. Okay, I'm just going to do an example now of maybe an inequality where you would need to reverse the sign. So let's say I had something like negative 4x plus 3 is less than 5. So start by taking away 3 from both sides, like this. So I would have negative 4x is less than 2. Now what I've got to do now, I've got to divide both sides by negative 4. Now when you multiply divide by a negative number, you reverse the sign. So actually it's still going to be x here, but now you flip the sign around so it becomes greater than, and 2 divided by negative 4, 2 divided by negative 4, well that's the same as negative a half or negative 0.5. Okay, so we probably write our final answer as x greater than negative 0.5. So we'll reverse that sign when we multiply or divide by a negative number. So we now move on to this bit here, which is solving simultaneous equations by balancing, substituting and elimination. The method that we really use is going to be the elimination method. And with the elimination method, the steps are that we need to multiply to make the numbers in front of x or y the same, or whatever letters you have. Then to look to see if we have the same sign. And if we have the same sign, we subtract. And then after that, it's going to be a simple equation to solve. Once you solve that equation, you need to substitute because we need to find the value of the other letter. Once we substitute, there will be another easy equation to solve. And then we can smile because we have now solved that easy equation. Right, so let's do an example. So let's have 4x minus 5y equals 4, and then 6x plus 2y equals 25, like this. So I'm going to make the numbers in front of x the same here, and I can make them both 12 by multiplying the first equation by 3 and the second one by 2. So let's do that and see what we get. So we will get 12x minus 15y, c times everything by 3 equals 12. And in the second equation, I will have 12x plus 4y, let's move that plus across a bit, plus 4y equals 50. So now I look at the numbers which are the same. So I've done this first step here. I'm now on to the second step. And if I look at those, these numbers here have the same sign. They're the ones I'm interested in. So we're not bothered about the other ones because those numbers are not the same. So we don't look at these signs here. Yeah, we look at the signs of the numbers which are the same, the ones that we've made the same. So because those signs are the same, we subtract. So if I now subtract, I will have negative 19y, because it's negative 15 minus 4, and then 12 minus 50 is going to give me negative 38. So if I divide both sides by negative 19, so we're basically on this step, we're solving this simple equation. I will have y equals 2. Okay, so we are halfway there. We have the value of y. The next step is to work out what the value of x is. So now we're on to the next step where we substitute. So I take that value of y equals 2 and I'm going to substitute it here. Yeah, now it doesn't matter which equation I substitute it into, but pick the easiest one. If I substitute it into there, I will have 6x plus 2 times y, which is 2, equals 25. So that's 6x plus 4 equals 25. So we're now on to this solve step. Yeah, so we want to solve this simple equation that we've got. So we'll take away 4 from both sides, like this, and we will have 6x equals 21. When we take away 4 from both sides, then we'll divide both sides by 6, like this, and we're pretty finished now. X will equal 21 over 6. Now we can simplify that. We can divide both of those by 3 and we get 7 over 2, which we could write instead as 3.5 or 3.5. So any one of those is fine. So our final solution is x equals 3.5, y equals 2. Now what we've found here is the coordinate where the two lines cross. So another way of solving equations simultaneously is to draw the lines like this and find the point where they cross. So you can do that by drawing a graph, or you can do that by the algebra method, which is what we've done here. The next topic is trial and improvement. And trial and improvement is trying to solve an equation, nonlinear equation, by trying a solution and then trying to find a better solution. So let's say I wanted to solve x squared equals 50 to 1 decimal place. And we're going to do it by trial and improvement. So I'm going to try some numbers for x. So I'm going to create a table where the first column says the values of x that I'm going to do. Second column is going to be my working. Yeah. Then I'm going to write some sort of comment here, and that will help me decide what I'm going to do next. So let's try 7. So if I try 7 in that equation, I get 7 squared, which is 49. I need to get 50, so my comment is that it's too small. So I need to try a number a bit bigger. So let's try 7.1. So if I try 7.1, so this would be a calculator paper. I'm going to do 7.1 squared. Let's do that. And that will give me 50.41. 50.41. So that's too big. This is how this trial improvement works. Okay, so we're going to try something a bit smaller. But because we are trying to find an answer to 1 decimal place, yeah, we've decided this is our values of x. We've decided that when we tried 7, it was too small. I know that when I tried 7.1, it was too big. Yeah. Now I don't need to try any other numbers. I just need to decide, so I could call that 7.0. Which one of these two numbers gives me an answer which is closer? And the way that we decide that is that we pick a number halfway in between them. So 7.05. And I'm going to decide whether this is too big or whether it's too small. So this is in between. In between the numbers which give me one which is too big and one which is too small to 1 decimal place. So I do 7.05 squared and I get 49. Let's write down the working. 7.05 squared, 49.7025. That one is too small. So let's have a look. Too small. Now our answer is always between the bit which is too small and the bit which is too big. So it's telling me the answer is somewhere in this gap over here, which means that my final answer is going to be x equals 7.1 because it's on that side. Now sometimes your table may be a bit bigger, there might be a bit more working to do, but this is basically how trial improvement works. You try a number, you see if it's too big or too small, then you try another number that might be a little bit bigger, a little bit smaller, but help keep track of what you're doing by drawing a number line. That's really useful, and then you can see where to go to next. Now we're on to this last topic here, which is to do with regions and plotting these regions using inequalities. Now I'm just going to show you the type of thing that you're going to get. So you'll have a grid with your x and y axis. You'll plot some lines. Some of those lines may have a dotted line to them. Some of them may have a straight line like this, or a solid line like that. And normally what happens is we do some shading like this. We're shading off some bits, and often what you're left with is like a bit in the middle which we label as R, and R stands for region. So how do we do all of this? Well, here's the steps. So the first thing, we need to plot the lines. Okay, now you're going to have things like y is greater than 5x plus 2, or x is greater than 5. The first thing you do is you make it equal to 5. like this. Okay, so when you plot the lines, make inequalities that you're given equal to, so put an equal sign there instead of a greater than or less than, then use a method, and there's methods that are on previous videos about plotting lines. Use a method to plot the line, or plot points and then draw the line. So plot points and join the line, or join the points that you've plotted. Okay, now we just need to make a note that if you have this symbol or this symbol, when you plot the line, draw a solid line. But if you have this symbol or this symbol, you draw a dotted line. Okay, so we're going to have all these different lines plotted. Now we need to decide which side to shade. So what you do is you pick a point on one side of the line, okay, and put it into the equation, or the inequality. Now put it into the inequality. When you put that point, so you pick a point, you'll get a value of x and y. You put that value of x and y into the equality, and you want to try and find out, when you put it in, you'll either get a statement which is true, or you'll get a statement which is false. Now, to make things easy, when we get a statement which is false, we shade it. If we get a statement which is true, we basically shade the other side. So we shade the other side of the line. So wherever we've picked our point, and when I put shade it, I should probably put shade that side where you pick the point. And then once you've done that for 2 or 3 or maybe 4 different lines, you'll have a diagram like you have here on the left.